We're going to talk about the first special right triangle, which is a 45, 45, 90 triangle. The 45 refers to the two angles that are both 45 degrees and an angle that is 90 degrees. In short, we call this the 45, 45, 90 triangle. When we are working with these types of triangles, they have a consistent pattern. And with a consistent pattern, we can find the missing side lengths without doing Pythagorean theorem. And so it makes it a little bit faster and easier. And with Pythagorean theorem, you have to know two sides to find the third side. And that is not the case with our special right triangles. In Pythagorean theorem, you had to know where your hypotenuse was. And so I'm going to remind us that that is still the case. We still need to know where our hypotenuse is. And one thing that I like to use is using the 90-degree sign. It actually makes a triangle, an arrow pointing at the hypotenuse. And so I always use that as like kind of a helpful reminder of where my hypotenuse is. Again, that would be across from my 90 degrees. So you'll notice I labeled that hypotenuse. Since a 45, 45, 90 triangle is an isosceles triangle, that means that these two angles are congruent, which we already discussed as 45 degrees. That also means these two sides are congruent to each other. So that can be really nice because if you know that this base is 5, you automatically already know that this base is 5. And I can keep on going through lots of numbers there, but what you need to know is if you know this base, you automatically always know the other base. And they're both labeled base because you can change the direction of the triangle, but those are still your bases. In our examples today, we are going to go through different types of 45, 45, 90 triangles, and we have to find the missing sides. Notice in example A, one indication they could give me that this is a 45, 45, 90 is the fact that they put a 45 degrees here. The other indication is the fact that they showed me that this side is congruent to this side. And notice I have X down here and I have Y here. So I want you to ask yourself every time you have these types of problems is what am I given? And that just needs to be the first thing you ask yourself because our notes are based on what's given. So if you were given the base, then you would multiply. If you're given the hypotenuse, then you divide. And so that pattern stays true every single time you have a 45, 45, 90 triangle. So if given the base, multiply by radical 2 to find the hypotenuse. So if I notice here, I am given a base. And going back to this picture, my base here is the same as my base here. So if I know that this value here, I automatically know this value here. So from the fact that this is 5, I already know that X is also 5 because the bases are congruent. So I automatically know that this is also 5. So if given base, then multiply by radical 2 to find the hypotenuse. I've already found that both of my bases are 5, and to find the y, I need to take the base, which is 5, and multiply by radical 2. And we reviewed multiplying and simplifying radicals last week. And if you have something that's out of jail and you have something that's in jail and nothing can simplify, then you'll just write your answer as 5 radical 2. And so I can actually show you this pattern many different times with just kind of covering this up. So anytime you're given the base, this base is 5, this base is 5, this is going to be 5 radical 2. So let's practice a few of those without having to draw different triangles. So for example, whenever I change my base, let's say now this is 10, so this base is also 10, and then my hypotenuse is going to be 10 radical 2. And that pattern stays with lots of different numbers. So if this is 50, then this base is 50, and this is 50 radical 2. Again, I could do this for a long time, but I just want you to understand that if we have an unknown, let's say x, this is x, and this would be x radical 2. The only thing you're changing is the value in front of the radical 2. Okay, so for part B, I tried to draw these kind of looking slightly different, and this one actually does not look like a 45, 45, 90 triangle, but it is because it shows these two angles are congruent. And since these two angles are congruent, that means this is an isosceles triangle. And since it's an isosceles right triangle, that makes this 45, 45, and 90. So ask yourself, what am I given? If I'm given base, I will multiply. If I'm given hypotenuse, I divide. Okay, so if I'm given base, which I am given the base here, which one is my other base? And so to remind ourselves, this makes an arrow to the hypotenuse. So y becomes my hypotenuse. This is a base. This is a base. And just identifying that is going to help me find my answer. So if this is 2 radical 2, then x is also 2 radical 2 because my bases are the same. If given base, then multiply by radical 2 to find hypotenuse. So I take 2 radical 2, and I'm going to multiply that by radical 2. We're going to review some multiplying radicals, and I'm going to put these twos in jail together. So if they're both in jail, they can go in jail together. They are going to circle up, and I have a 2 outside waiting. I have another 2 come out and join. This one's gone. No one is stuck in jail, so I don't need to leave my jail there anymore. And once they're outside, they do multiply. So y equals 4. So my two answers are x equals 2 radical 2 right here, because they're both bases, and my hypotenuse is y equals 4. Once you get really good at this pattern, you don't have to doubt yourself, and you don't have to do Pythagorean theorem to prove that this works. I can show you Pythagorean theorem and make sure you understand this works, and I'll do that in a different video. But this is the pattern that works for 45, 45, 90 triangles. Okay, so for my next picture, kind of ran into this example, but notice I have these dashes here. They're showing that this side is congruent to this side. I also forgot my x and my y, so I'm going to put my x and y in there. The y is not always a hypotenuse. I just have a tendency to draw it always on the hypotenuse, but it could be any variable, x, y, z. Again, I want to ask myself, what am I given? And in this case, I am given the base again because my bases are congruent. So I already know that x is 3 radical 3 because my bases are the same value. So if given the base, then multiply by radical 2 to find the hypotenuse. So I'm going to take 3 radical 3 times radical 2. When I put 3 and 2 in jail together, 3 does not factor tree more, 2 does not factor tree. I cannot pair them up and try to escape jail, so I'm just going to leave them as 3 radical 6. If they're stuck in jail, they can multiply it back up. And it's uncomfortable that an even number is in jail, but if nothing simplifies, then I will just leave it.